Hello students, I am Sonali Kelkar from City International School, and today we are going to take all the equations of chemical equations. I'll see if I am able to complete all the equation in this session, or we are going to continue in the other session. Okay. So the first chapter of your chemistry, that is chemical reactions and equations. Now let's see the first equation of this chapter. I am going to tell you about the equation, why this equation had happened, what is the result, what is the color of the product, because the question will be based on this equations, right? So let's start with the first one. The very first equation of your book is magnesium when react with oxygen gives magnesium oxide, right? Before you come to any conclusion, you have to write the equation and then you have to balance the equation, right? So I have taught you how to balance the equations. So let's see whether the equation is balanced or not. Over here, magnesium, initially it was magnesium plus oxygen gives MgO, right? Then what happened? What I did is I found that there is 2 atoms of oxygen. So here there was only 1 atom of oxygen. Okay. So when oxygen it was 1, so I made it 2, right? I wrote 2 over here, and when I wrote 2, the magnesium has become 2. But it was initially 1 over here, so I have to put 2 over here. I have written a balance equation, but when you are writing the equation, you have to be very much sure that after you complete the equation is balanced or not. Now why do we balance equation, right? What is the question? Why do we balance the equation, sorry? Okay, we balance the equation because of the law of conservation. So according to the law of conservation of mass can neither be created nor be destroyed. So no more atoms are formed in this reaction. Whatever the atoms were there initially, that means whatever the atoms were there in the reactant, the same number of atoms will be there in the product. Okay. So let's do the second equation. This second equation is based on the activity in your book, where in the conical flask they have put we have put zinc granules, and on the zinc granule the hydrogen chloride acid was poured. Okay, but this reaction has to be done very carefully. Okay, in this reaction, when zinc react with chlorine, you are getting zinc chloride, ZnCl2. Here you need to know, very important thing is you should know the valency of zinc. The valency of zinc is 2 plus and the valency of chloride is 1 minus. So, okay, so that's why the chloride valency will come here, zinc valency will go under the chloride. I'm sure that you have done the formation of compound last year. Please revise all these concepts one more time, because these are the basic of chemistry. And in further chapters also, acid, base and salts, you need to know more about the chemical compound. So keep revising the chemical compounds. Okay, so ZnCl2 and hydrogen gases evolve, it is liberated. Okay, then how can you check whether the gas liberated is hydrogen gas? So what you have to do, bring the burning splinter, a pop-up sound will come. This proves that the gas liberated is hydrogen. Okay, this in this experiment you can do the same experiment with the acid HCl, hydrochloric acid, or sulfuric acid, right? H2SO4 is a sulfuric acid, and what about H2SO3? Okay, what is H2SO3? It is sulfurous acid. Okay, so let's start. Zn plus zinc plus H2SO4 gives ZnSO4. Now if you remember hydrogen, because this is a revision class, so I can ask random question also, whatever I have taught in our previous session. Okay, so you can see the hydrogen is replaced. Okay, it is replaced by zinc. So which type of reaction is this? We can say that it is a displacement reaction also, right? So ZnSO4 is formed, which is a compound, and hydrogen. Now let's see whether the equation is balanced or not. Okay, so zinc, number of atom in zinc over here is 1, 1. It's hydrogen is 2 over here, 2 means on the reactant side and 2 on the product side. Okay, SO4 and SO4, so this equation is completely balanced. Okay, now coming to this equation, carbon monoxide plus hydrogen, 340 atm. atm is a short form of atmospheric pressure. So under 340 atmospheric pressure, when carbon monoxide and hydrogen gas react, they are going to make CH3OH, that is methyl alcohol, right? OH is a alcohol group. Fine. So methyl alcohol. Now let's see whether this equation is balanced or not. Okay, carbon here is 1, carbon here is 1, hydrogen is oxygen is 1, hydrogen is 3 over here, hydrogen is 2 over here. So if I write 2 here, it will become 4. Let me write 3 here. So hydrogen is 6 over here. If I write 2 here, okay, hydrogen will be 6 plus 1, 7. Okay, carbon is 2 over here. Okay, so carbon over here 2, oxygen is 2, carbon is 2, but what about hydrogen? Hydrogen is still not balanced, so you need to balance hydrogen. Okay, you just write 2 here, hydrogen is 4, and over here CH3OH, 3 plus 1, 4 hydrogen, and this is also 4. Clear? Now you can rub this. Yeah, as we know that balancing of equation is in trial and error method. Okay, so you can use any type of method, and if you want you can cut and rub and balance the equation, final equation. Let me see number of carbon atoms here. Okay, so let it write carbon, oxygen and hydrogen. Fine. So carbon on the reactant side is 1, on the product side 1, then oxygen on the reactant side is 1, on the product side 1, hydrogen on the reactant side is 4, yes, and over here 3 plus 1, 4. Now the equation is completely balanced. Clear? So let's go to the next equation. Children, I am not teaching you over here the basic way of balancing the equation, because that I have already taught you. By this time you should have practiced it. Okay, so I am not going in detail of balancing the equation. Okay student, the next equation is about photosynthesis, and what we do in photosynthesis, it is carbon dioxide. Okay, carbon dioxide plus water in presence of sunlight and chlorophyll. Carbon dioxide, water reacts in presence of sunlight and chlorophyll, gives glucose, and oxygen is released. Clear? So now you have to balance this equation, right? So how you are going to balance the equation? See the number of carbon atom, oxygen atom, hydrogen atom on the reactant side. So let me write carbon, hydrogen and oxygen on the reactant side, right? And number of atoms of carbon, hydrogen, oxygen on the product side, right? So let's see the carbon, number of carbon atom over here 1, oxygen is 2 plus 1, 3. Clear? Hydrogen is 2. Okay, oxygen is 3 and hydrogen is 2. Fine. Now coming to the product side, carbon is 6, Okay, hydrogen is 12 and oxygen is 6 plus 2, 8. Fine. Now let's start with hydrogen. Why are we starting with hydrogen? Because according to the rule given in your book, we have to start with a atom which are more in numbers. Okay, the highest amount of atoms, so that is hydrogen. So if the hydrogen is 12 here and 2 here, so to make this 2 into 12, what I am supposed to do, I will multiply this 2 with 6. Clear? So hydrogen is now balanced. So hydrogen got balanced. What about the oxygen here now, right? Oxygen has become 6 here. Now instead of 3, it becomes 6. So I will write 6 here. Okay. Now 6 and 8, 8 over here. Now what is the common multiple of 6 and 8? Least common multiple, LCM, right? That is 18, right? Isn't it? So 18 comes in 6 table and 8 table. 18. So let's do this 6 table and 3 tables. Okay, table of 6 and 3. Fine. So oxygen is 6 here now and 8 here. So what do? What I have to do is, if I put here 6, okay, now it will become 6 into 2, 12, 12 plus 6, 18, right? And here was 6 plus 2, 8. So if I put 6 here, now here also I am getting 6 into 2, 12 into, 6 into 2, 12 plus 6 is 18. So even oxygen got balance. So here oxygen 18, here also 18. So even oxygen get balance. Now carbon here has changed into 6. So carbon get also balance. Now this is a complete balanced equation of photosynthesis. Okay. See, balancing of equation is something which where you have to do trial and error method. Okay. So keep doing it, keep practicing it. Okay. So that you will become perfect and you can balance the equation fast. Correct. So these were the different type of equation given in your book. Let's see few more equations, right? Let's start the combination reaction, children. Okay. What is a combination reaction? It is a reaction where 2 or more reactant combines to form one product. So let's take the reaction let's take A plus B are 2 reactants, they combine to form AB. There can be 2 and more than 2 reactants which can combine to form one product. Okay, so there is an activity in the book where the quicklime is added with water, and this reaction is very vigorous reaction. In this reaction heat is liberated. Okay, as we know that chemical reaction can be reaction, one of the characteristic of chemical reaction where the heat is liberated. Okay, so this is what is the reaction. Let's see the reaction. Quicklime, which is nothing but calcium oxide, when you add water slowly to the crystals of calcium oxide, you have to add it slowly because heat is liberated, and this is very vigorous reaction. So when you add calcium oxide and water, you will get a product which is calcium hydroxide, which is also known as slaked lime, right? And heat is liberated. Now this aqueous solution of slaked lime is also used to whitewash walls. Okay, so when we whitewash wall with slaked lime, we will see that after 2-3 days there will be a shiny appearance in the wall, on the wall. So this is because carbon dioxide which is present in the air will react with calcium hydroxide and calcium carbonate will be formed. So due to the formation of calcium carbonate, this shiny appearance on the wall is there. Okay, water will be released. Now I have written the different forms of these reactants. Okay, calcium carbonate solid, water liquid, and calcium hydroxide aqueous. So you need to write all this information about the reactants and product when you do these type of reaction. One more thing here I want to add, that even the marble has a formula, chemical formula for marble is calcium carbonate. So calcium carbonate is a compound which has a shiny appearance. Now there were equation which we did in types of chemical reaction, right? So what type of chemical reaction we did? We did combination reaction, decomposition reaction, displacement reaction, and double displacement reaction, and redox reaction, right? So all the reaction we are going to take one by one, okay, and the equations given in that reaction. Now let's do the next equation of combination reaction, where carbon is reacted with oxygen. Carbon react with oxygen. This carbon is nothing but coal, okay. When you burn coal, what happened? What happened when you burn coal? Which gas is formed? When you burn carbon, which gas is formed? Carbon dioxide is formed. So this is a gas, fine. This is also gas, and this is solid. This is coal, okay. So this is an example of exothermic reaction. I think it's balanced. Single carbon atom here, 2 atoms of oxygen, 2 atoms of oxygen. So it is a balanced, right? So this is exothermic reaction. What is the next reaction? Hydrogen plus O2, H2 plus O2. Children, what will form? Hydrogen and oxygen. Okay, when combined together, what happened? What is formed? This is the perfect reaction of chemical reaction. This is what happened in chemical reaction, right? Two reactants react together and a product is formed, and the property of the product is absolutely different from the property of the reactant. It can be different, much different. Over here we can see hydrogen and oxygen are gases, whereas water is liquid, okay. So you can put liquid here, gas and gas. Now see whether it is balanced or not. It is not balanced because oxygen over here is 2, over here is 1. Hydrogen is balanced. So let's balance the oxygen. So over here 2, 1, so I will write 2 over here. Done, right? Now what happened to hydrogen? It has changed. Now hydrogen is 2 into 2, 4. So I need to balance this hydrogen also. So what I am going to do, just write 2, okay, least multiple of 2, okay, it's 2 and 1. So this is balanced. Now coming to the next equation. So I have place, okay, let me write over here. Methane, here the burning of natural gas. The next is burning of natural gas, that is methane. CH4 burn. We know that when you have to burn something, which is the important gas required, oxygen, right? So when you have to require oxygen, so you need to write O2. Okay student, now let's take the next reaction of combination reaction. Again it will be a exothermic reaction, okay. Now here the natural gas, that is methane, CH4 is methane, okay. Methane is burnt. Of course, when the anything, if you are burning anything, you require oxygen gas. So for that you need to write O2. When methane is burned in presence of oxygen, methane is carbohydrate, it burn in presence of oxygen, it will liberate carbon dioxide, gas is formed and water is formed. Here you need to remember one important thing. Whenever you burn carbon compounds or carbohydrates, what gas is released is carbon dioxide. Carbon dioxide will definitely release and water will also release. Clear? So now let's balance the equation, right? So let's see. Carbon here 1, here also 1, right? Hydrogen 4, and here the hydrogen is 2. So I'll make this 4. So 2 into 2, 4. Now hydrogen is balanced. What about oxygen? Oxygen over here is 2. Over here 2 plus 2, 4. So I need to put 2 over here. Okay, now it is balanced. Clear? So this is one more equation is left in a combination reaction. We will quickly finish that equation and I'll stop the session here. In the next session we are going to continue with the rest of the equation. So in this equation, glucose C6H12O6, okay, glucose is burnt. Okay, it is used by our body. What is formed when the glucose is burned? Carbon dioxide is released. This is a respiration reaction. Okay, so carbon dioxide gas is released plus water will be released. I told you before, when carbon compounds burn, carbon dioxide release and water also release. Okay, or water is also formed. Plus, because this is a respiration reaction, so sorry, one more thing I have to write over here. Respiration reaction takes place in presence of oxygen. Clear? Right. So energy will be liberated. Okay, energy will be liberated. So let's see whether the equation is balanced or not. C6H12O6, right? Let's see, carbon. For big equation you need to write a proper step. For the small equation you can try to do it mentally or you do it mentally. Okay, carbon, hydrogen and oxygen. Carbon here in the reactant side 6, hydrogen 12, oxygen 6. Okay, sorry, oxygen 6 plus 2 8. Directly write 8. Fine. Now coming to the product side, carbon is 1, oxygen is, hydrogen is 2. Now oxygen is 2 plus 1 3. Clear? Now what you have to do? So let's start with hydrogen because it has more number of atoms. So over here hydrogen 12. So what you have to do? Multiply with 6. If I multiply with 6, I will get 6 into 2 12. Right? So the hydrogen has been balanced. Now what about, let's see the carbon, right? Carbon here 6, here 1. So easy to balance, so I am taking carbon first. So I'll write 6 here. So carbon got balanced. Now coming to the oxygen, right? So oxygen here 8 and over here now the oxygen has changed. Now over here 6 into 2 12, 12 plus 6 18, right? Over here 6 is already there, so I can write over here 6. So 6 into 2 12 and 12 plus 6 18. Hence we have balanced the equation. And now you can write this glucose is in the aqueous form. For aqueous form you have to write AQ. Okay, oxygen is also in a form of aqueous, carbon dioxide aqueous, water liquid, and energy is released. This is also exothermic reaction. So today I am going to conclude this lecture over here. Practice all the equations which are given in your book, students, and thank you so much.